Hi there, so here's another topic. Say we have this form, terms, say our d is in this form, and as a function of x and y dx plus nx y dy. So last time we've have this form also, and say if we check that, or if we say we cannot do the separable equation, say this equation is not separable, or we cannot do the homogeneous coefficients, and say this given differential equation is also not exact. Okay, so if that is the case, then we can now have the what we call integrating factor. The role of this integrating factor is very important, because if we can now determine the so-called integrating factor, um, this integrating factor here transform can transform a non-exact equation into exact equation. Okay, and then after transforming this equation into exact, then we can now proceed to the steps of exact equation to finally find our general solution or the particular solution. Okay, so once again, if uh, all other techniques is not applicable, and you evaluate this given DE and it is not exact, then we can now look for an integrating factor, wherein this integrating factor, when multiplied to our equation, can make our non-exact equation into exact. Okay, so this integrating factor from not exact or non-exact to exact. So we will gonna transform a non-exact equation to exact. Okay, so the important thing to do is to find this what we call the integrating factor. Okay, so how can we determine the integrating factor? We have two conditions. Okay, if the partial derivative of m with respect to y minus n with respect to x all over n is purely a function of x alone. This is a purely a function of x alone. If this yields to purely function of x alone, then we can now use the integrating factor, which is equal to e raised to integral of this function dx. Okay, and then if this partial derivative all over the what we call this partial derivative of m with respect to y minus n with respect to x all over negative n yields to purely a function of y, purely y, and then we will use this as our integrating factor, e raised to f of y, g of y dy. Okay, so for illustration, let's now have a simple example. Okay, say we have this equation. We have a given DE, x squared plus y squared plus x plus x dx plus xy dy is equal to 0. Say we have this equation and we need to find the solution for this given equation. So let's now check if this is an exact or a non-exact equation. So by this is our m because it's multiplied by x, and this is our n because it is multiplied by dy. So our partial derivative of m with respect to y is, now we treat x constant, so this is 0 and then the derivative of 2y, I mean y squared, is just 2y, then this is 0, while the partial derivative of n with respect to x is just, we only need to consider x and let our y as constant. So the derivative of x times some constant is just the constant. Okay, and as you can see here, y is not equal to nx because 2y is not equal to y. Okay, so this given equation, the given equation is not an exact equation, not exact. Okay, so if this is not exact, then we need to make this equation exact by finding the integrating factor. Okay, so how? Let's use these two conditions. So we need to determine which condition is applicable. So according to our first condition, we need to minus the try m y minus n x all over n. Okay, so let's try. So our partial derivative of m with respect to y is 2y minus this part here is equal to y all over our n is, what is our n? xy. Okay, so let's simplify. Let's factor out y. So we have 2 minus 1, right? 2 minus 1. Oh, maybe we can now directly minus the 2y minus y. So we have 1y or y all over xy, and from here you can easily see that we can cancel out the value of y, so we have 1 over x. Okay, and as you can see here, this part here is purely x. Okay, purely function of x. So immediately we can now say that our integrating factor is this part. Okay, so how can we determine the integrating factor? We will use this e f of x dx. E integral of f of x dx. Okay, wherein this is equal to e integral of our f of x is 1 over x dx, and then by integrating this we have e raised to ln of x, right? Because the integral of 1 over x is just ln of x. And then we have e raised to ln of x, e raised to ln. So this is now x. Okay, so our integrating factor is x. Okay, so our next step, if we the next step after finding the integrating factor, the next step is to multiply this integrating factor in our original DE. Okay, this part. Okay. This part. Copy. Let's copy this. Okay. Okay. So using this part, we will multiply our DE. Say this is our equation 1. So make the we will make the equation exact by multiplying the integrating factor to equation 1. Okay, so this is our equation 1, and we will now multiply our integrating factor. So by multiplying our integrating factor in this whole term here, we have x cubed plus xy squared plus x squared dx, plus also to this part we have x squared y dy is equal to 0. Okay, and from this given dE, let's now try to recheck if we can now have an exact equation. Okay, so m y is equal to, this is our m, this is our m. So we have the partial derivative with respect to y. So since this is x, this is now 0, and then plus xy squared since this is constant. So let me write this x, and then the derivative of y is 2y. Okay, and then this is also a 0. And for this part, we have n with respect to x. This part will only consider variable x. We let y as constant. So we have y as constant, and then the derivative of x squared is 2x. So I forgot to simplify this one. So by simplifying, we have 2xy, and also for this part we have 2xy. As you can see here, the partial derivative of m with respect to y is now equal to the partial derivative of n with respect to x. So they are now equal, which only means that we already make our original or our given differential equation into exact equation. And from this point, we can now solve the general solution or particular solution if we have a given condition. We can now solve this solution by adapting or by doing the steps in exact equation. Okay, so if you do these steps to solve the exact differential equation, then the answer yields to plus x squared y squared is equal to c. Okay, so this will gonna be the general solution. Okay, so I will leave you the computation or the steps on how to make or how you can arrive in this general solution. Okay, you must do the exact differential equation from this using this transformed dE here. Okay, so that's all for this video, and see you next time for more examples.